Hello. Namaskar. Welcome to Santachemistry, and I welcome you all to the bumper lottery of 12th chemistry. Yes, bumper lottery of 12th chemistry exam, and that is ninth chapter coordination compounds. Why am I calling it bumper lottery? Because it is. This chapter is asked in exam for minimum 8 marks. 8 to 10 marks. Last year, the questions from this chapter were asked for 10 marks. Can you imagine? So it is highly valued chapter. Okay, in this video, we'll try to cover everything from basics to advanced. After watching this video, if you practice well, I guarantee you minimum 8 marks from this chapter for sure. Okay, we'll try to cover all the topics, all the PYQs as well. So stay tuned till the end and subscribe the channel if you have not done till now. Okay, so let's begin. Let's begin with the basic of this chapter. When I say coordination compound, what do we have here? One central metal, a metal and a ligand. That is the base of this chapter. Okay, one metal, any metal will be called as central metal, and a ligand is something new to us. So ligand is the one which connects, which gives electron to the metal center. Okay, so there are three different things: one metal, one ligand, and that ligand gives electron to this metal. So we call it coordinate bond. What is coordinate bond? Bond formed when both electrons are donated or given by the same element or same atom. Not the proper word, I'll say shared by the same atom or same element. Okay? So that is coordinate bond, and since this molecule has a coordinate bond, आपण याला म्हणतो coordination compound or coordinate compound. Okay with it? Fine. Now what is ligand? Ligand is the one that gives electron, and metal is the one which accepts electron in this molecule. Okay? Hence we call this ligand as Lewis base. म्हणजेच electron pair donor. Whereas metal will be, it is accepting na, so it is called as Lewis acid, or we can say electron pair acceptor. Okay, is this clear? This is very basic about this topic. Okay, now we'll see what is meant by ligands. There are different types of ligands, so let's quickly go for that. Okay, now let's discuss types of ligands. As I said previously, ligands are electron pair donor, also known as Lewis bases, because they give electrons. Okay, there are mainly three different types of ligands. Very first one is monodentate. म्हणजे काय? So it has only one donor atom. Monodentate, polydentate and ambidentate. Total three different types of ligands are there. अब सगळ्यात पहिल्यांदा what is meant by monodentate ligands? क्या होता है ये? तो इसमें सिर्फ एक इलेक्ट्रॉन पेयर है, सॉरी एक इलेक्ट्रॉन डोनर एटम है. ओके, सिर्फ एक इलेक्ट्रॉन डोनर होगा तो इट इज मोनोडेंटेट. एग्जांपल Cl-, H2O, NH3, Cl-, इन सब में अपने पास बस सिर्फ एक इलेक्ट्रॉन डोनर एटम है. ठीक है. देन व्हेन आई से पॉलीडेंटेट, इट हैज मोर देन वन डोनर एटम. इफ इट हैज ओनली वन, monodentate. If we have more than one, we call it polydentate. And in case of polydentate, we have bidentate and hexadentate. When I say bidentate, from name itself we can conclude bi म्हणजे दोन, right? Bi का मतलब होता है two. So if a ligand has two donor atoms, we call it bidentate ligand. Okay? Example, ethylene diamine. Ethylene diamine has CH2, CH2, and here we have NH2. Here we have one more NH2. So that N, those N's are electron donor atoms. Okay? We have two, so it is called as bidentate ligand. Okay? Then we also have oxalate ion. Oxalate ion is also an example of bidentate ligand. 1 and 2. Both oxygen can give electrons easily. Okay? Not easily, but yes, they give electron. Hence it is bidentate ligand. Hexadentate. Hexa means 6. So it has 6 donor atoms. We have only one example for this, and that is EDTA ion. EDTA stands for ethylene diamine tetraacetic acid. But when I say ion, we have ethylene diamine tetraacetate ion. Tetra means 4. Here we have 4 minus charge. So it should be 4 minus ion. Okay? EDTA 4 minus ion. Ethylene diamine tetraacetate ion. It is just what do you say? Improvement or modified version of this one. CH2, N, N. Just these hydrogens are replaced by acetic acid group. So here we have CH2 instead of this H, we have CH2, C double bond O, O minus. Similarly here as well as here. Draw the structure properly and try to practice. Can be asked in exam for 1 mark. Okay? Though the recently was not asked, but we should practice it. Okay? Zamil? Fine. Now the next one is very important. Ambidentate ligand. Ambidentate means it has 2 donor atoms, but at a time only 1 donor atom can give electrons. Okay, it's like Shaktiman and Gangadhar are the 2 different काय म्हणतो आपण तर दोघंही एकाच ग्रुप आहेत, बट एका वेळेला फक्त एक असणार. फाइन. सो हियर वी हॅव 2 donor atom and out of 2 at a time only 1 can donate. SCN minus is example. So sometimes S can give electron, sometimes N can give electron. Okay? Then NO2 मध्ये पण परत तेच. Sometimes N can give electron, sometimes O can give electron. So at a time only one of them can give electrons. Okay? That is all about types of ligand. We have covered it. Take a screenshot of this, note down each and everything in your notebook. Now we'll move to the next topic. The chapter is full of topics, but don't worry. When Santosh sir is here, everything is easy. Okay? Take a screenshot. We'll move to the next topic. Okay. These are the 3 questions which are asked recently in exam on the basis of types of ligand. So, सगळ्यात पहिला प्रश्न काय बघा. The very first question is explain monodentate and ambidentate ligands with example. मतलब हमें यहाँ पे explain करना है कि what is meant by monodentate ligand, what is meant by ambidentate ligand और उसके example देने हैं. तो what is meant by monodentate? 1 donor atom. Ambidentate क्या होता है? Has 2 but at a time any one can donate. बरोबर? It has 2 donor atoms but एका वेळेला फक्त एकच can donate electron. Okay? Then example of this we can simply say, for here we have Cl minus, then for here SCl minus for this. What are bidentate ligands? Bidentate means it has 2 donor atoms. Has 2 donor atoms. Example can be ethylene diamine or oxalate ion. Okay? Got to 2 marks. Write the name of hexadentate ligand. We have only seen one hexadentate ligand, and that is ethylene diamine tetraacetate ion, that is EDTA 4 minus ion. Okay, so with this we have got 3 questions done on ligands. Okay, I have not written answers properly, but if you are comfortable, take a screenshot of this, and if not, try writing by yourself. Just copy the questions. Okay, we'll see you in the next topic. Okay, now the next concept, important terms involved in coordination chemistry or coordination compound. सगळ्यात पहिल्यांदा कोऑर्डिनेशन स्फीयर. व्हाट इज मेंट बाय कोऑर्डिनेशन स्फीयर? क्या होता है वो? सो इट इज द सेंट्रल मेटल आयन और एटम and ligands are enclosed in a square bracket. Okay, central metal atom and ligands enclosed inside a square bracket known as coordination sphere. Okay, so this will be called as a coordination sphere. Coordination sphere. Okay, and here this will be called as a coordination sphere. Counter ion or ionization sphere. What is meant by that? अगर इसमें स्क्वायर ब्रैकेट के अंदर वाला था कोऑर्डिनेशन स्फीयर, तो व्हाट विल बी द आयोनाइजेशन स्फीयर? स्क्वायर ब्रैकेट के बाहर वाला. ओके, सो द आयोनाइजेबल ग्रुप shown outside the bracket are counter ions or we call it ionizable sphere, ionization sphere. So this is coordination sphere, and this will be called as counter ion, or I'll call it ionization sphere. Okay, एकदम easy, simple term. चलो note down. We'll see you in the next topic. Okay, so now the next important topic is coordination number. Question can be asked on this for 1 mark, especially in MCQs. Okay, so please need focus kara and let's discuss what is coordination number. It is quite simple. It is the number of ligand donor atoms directly attached to the metal. Okay, ligand donor atoms, not the number of ligands. Ligand donor atoms. Okay, now in this let's check. Here NH3 is a monodentate ligand and Cl is also a monodentate ligand. So how many nitrogen in ammonia, or how many ammonia are there? Total 4. Monodentate, monodentate. 4 plus 2, 6. So here in this case Cn will be equal to 6. Okay, because all ligands are monodentate. Okay, here in this case C2O4 is this one, COO minus, COO minus. So it is a bidentate ligand. One ligand will give 2 donor atoms. Total we have 3 ligands. So it will be 6 donor atoms. So please be very careful about this. It is bidentate. Should be able to identify which ligand is present. Fine. Here we have bidentate ligand and we have 3 of such type. So the Cn is equal to again 6. याचं कारण काय असणार आहे? All ligands are bidentate. Since they are bidentate, म्हणून एकामध्ये 2 donor atom. Total we have 3. 3 to 6. म्हणून coordination number is 6. समजताय? Okay. There are some questions which were asked in exam. These are MCQ questions. Question number 1 was asked in November 2020. Question is, find the coordination number of cobalt in CONH3 6 times. Bracket sum hai Cl2. Again, we can check here. NH3 is a monodentate ligand, so it is giving 1 electron, 1 donor atom only, and we have total 6. So here for this one the Cn will be equal to 6 again. Here find the coordination number of cobalt in COCl2 En twice. 2 plus 2 4 ना? Correct है? अजिबात नहीं. Cl is a monodentate ligand, but ethylene diamine, check your notes, we have discussed that previously. Ethylene diamine is a bidentate ligand. So if ethylene diamine is a bidentate ligand, one ligand will give 2 donor atoms. बरोबर? We have total 2. So 2 to 4. 4 आणि Cl चे 2 टोटल झाले 6. सो अगेन कोऑर्डिनेशन नंबर फॉर दिस विल बी 6. Okay with that? Fine. Note the questions and remember coordination number is equal to the number of ligand donor atoms attached to the metal center. Okay? Let's see what is meant by double salt and complex ion. Okay, chalo. Take a screenshot. We'll move to the next one. Okay. Now the next topic. And exam madla important question, that is double salt and coordination complex to a coordinate compound. Okay, question was asked in September 2021. The question is, illustrate the example the difference between a double salt and a coordinate compound. Sometimes they can say coordination complex. Okay, now what is the basic difference, what is the major difference between them? Coordinate compound contains at least one complex ion, and double salt is it goes into water to give all the ions. That is the major difference. Okay, so let's see what is the what answer we have to write for 2 marks. Okay, so double salt काय असतं, dissociates in water completely into simple ions. Fine. And coordinate compound dissociates in water with at least one complex ion. Okay, what is the example here? Potassium hexacyanoferrate 2. Don't worry, we'll learn the nomenclature as well. For now, potassium hexacyanoferrate 2 is this complex. This complex goes into water to give ions in this format. This is a counter ion. This counter ion will dissociate completely, and this inside the bracket coordination complex will remain undissociated. That is known as counter ion. Okay, that is called counter ion. याला म्हणतो आपण complex ion called as complex ion. And here more salt FeSO4 dot NH4 twice SO4 dot 6H2O when goes into water, it dissociates into all of its ions. Okay, that is the major difference between these two. And double salt gives positive test for all of its ions. Okay, and coordinate compound gives positive test only for counter ion because this do not ionize. Okay, fine. Take a screenshot of this and हे इथं लिहून practice करा. We'll move to the next topic. ठीक है? Okay. Now the next topic is classification of coordination complexes. Okay, so classification can be done in 2 ways, or we can say on the basis of 2 ways. Number 1 या फिर A and let's say B. A is on the basis of type of ligand, or you can say nature of ligands, and second on the basis of charge. So let's say the first one, on the basis of type of ligands. On the basis of type of ligands, we can classify coordination complex into 2 categories. Number 1 is homoleptic. Now what is meant by homo? Homo means same, बरोबर? So what is meant by homoleptic complexes? Contains only one type of ligand. Okay, contains only one type of ligand. We call it homoleptic complexes. And what is meant by heteroleptic complexes? Hetero means different. Okay, so contains more than one type, which is obviously different type of ligands. Simple. Okay, let's see the examples. Homoleptic, only one type of ligand, that is cyanide, Cl. Okay, and when I say heteroleptic complex, heteroleptic means more than one type. So here we have NH3 and Cl. We have 2 different types of ligand present here, so we can call it heteroleptic complex. Clear? Simple. Okay, now on the basis of charge, we can classify complexes into total 3 different types. Okay, cationic, anionic and neutral complex. आता what is meant by cationic complex? Cation म्हणजे काय? Having plus charge. anion क्या होता है? Having minus charge. Neutral मतलब उस पे कोई charge ही नहीं है. Simple. So when I say cationic complex, it will have a positive charge. When I say anionic complex, it will have a negative charge. When I say neutral complex, it has no charge. Is it that simple? Yes. But is it has no charge, मतलब कौन has no charge? So coordination sphere. So coordination sphere is positively charged, मतलब cationic complex. एनायनिक का मतलब क्या होगा? कोऑर्डिनेशन स्फीयर इज नेगेटिवली चार्ज. ये बॉक्स के ऊपर, ब्रैकेट के ऊपर अगर नेगेटिव चार्ज है, वी कॉल इट एनायनिक कॉम्प्लेक्स. अगर वो बॉक्स के ऊपर कोई चार्ज ही नहीं है तो वी कॉल इट न्यूट्रल कॉम्प्लेक्स. क्लियर है? ओके. यहां पे ना एक बहुत बार कंफ्यूजन होता है. अगर समझो मैंने बात किया इस वाले लिगैंड का, इस वाले कॉम्प्लेक्स का, तो ये कौन सा कॉम्प्लेक्स है? कैटायनिक है, एनायनिक की न्यूट्रल है. तो लेट्स दैट हियर ये समझो, अगर मेरे पास कोई काउंटर आयन प्रेजेंट है K4 FeCN लेट्स से 6, तो आइडियली इस पे कोई चार्ज दिख नहीं रहा है हम लोग को, लेकिन इसका मतलब ये नहीं कि न्यूट्रल कॉम्प्लेक्स है. तो ऐसे केस में करना क्या हम लोग को? यहां पे चेक करना है काउंटर आयन है कि नहीं है. सो इट्स अ ट्रिक टू रिमेंबर. अगर काउंटर आयन उसके पहले होगा, अब काउंटर आयन कौन है? पोटेशियम. पोटेशियम इज अ मेटल, मेटल्स आर पॉजिटिव. सो यहां पे ये निकलेगा एज अ प्लस. अगर काउंटर आयन प्लस होगा तो कॉम्प्लेक्स पे चार्ज माइनस होगा. समझा ये पॉइंट? तो जब भी तुम्हारा काउंटर आयन पहले आएगा कॉम्प्लेक्स से, इसका मतलब कॉम्प्लेक्स मस्ट बी एनायनिक. इससे उल्टा अगर मैंने लेट्स से ऐसा कॉम्प्लेक्स बोल दिया CO NH3 4 टाइम्स Cl2 Cl2 Cl2, ठीक है, और बाहर आ गया Br, बहुत करीब हो गया, पर ठीक है. अगर मेरे पास कोई ऐसा कॉम्प्लेक्स है जिसमें काउंटर आयन बाद में आ रहा है कॉम्प्लेक्स के, तो इन दैट केस रिमेंबर, अगर काउंटर आयन बाद में, वहां पे कौन है? Br. Br इज अ नेगेटिवली चार्ज लिगैंड, तो वो जाएगा एज अ Br माइनस. इसका मतलब कॉम्प्लेक्स विल हैव प्लस चार्ज. इसका मतलब ये कैटायनिक कॉम्प्लेक्स है और ये एनायनिक कॉम्प्लेक्स है. समझ में आ रहा है ये पॉइंट? ओके, आई विल मेंशन दैट हियर. दिस इज anionic complex and this is cationic. Okay, fine. I'll just move ahead, move outside, take a screenshot of this, and then we'll discuss Werner theory, which is also important question. Okay, before we go into that, look at the question. This question was asked on the same topic in March 2023. Okay, question is explain cationic, anionic and neutral sphere complexes. Okay, it was with example, it was asked for 3 marks. For explaining this you are getting 3 marks. Okay, so please take a screenshot of this and we'll see you in the next topic. Okay, चलो पढ़ करें. Okay, now the most to know question which is becoming favorite in recent years. म्हणजे this question was asked back to back 3 years, July 22, July 23 and March 24. So it is important. Okay, let's look at the question. क्या question है ये? Write the postulates of Werner theory of coordination complex. Okay, the question is about Werner theory. The same question was asked 3 times in recent years. By the way, in July 2024 it was not asked. Okay, so the chances are very high and the question is very simple. Okay, there are 4 postulates. Let's look at the answer. So Werner theory says it has total 4 postulates. First postulate says in a coordination complex, metal has 2 types of valencies. Okay, मेटल के 2 वैलेंसी होते हैं. नंबर 1 वैलेंसी इज कॉल्ड एज प्राइमरी वैलेंसी, नंबर 2 वैलेंसी इज कॉल्ड एज सेकेंडरी वैलेंसी. एकदम सिंपल, राइट? जो पहला वैलेंसी होता है प्राइमरी वैलेंसी और जो सेकेंड वैलेंसी होता है वो होता है सेकेंडरी वैलेंसी. डिफिकल्ट है? नहीं? वेरी गुड. देन सेकेंड पॉइंट सेज प्राइमरी वैलेंसी जो है इट इज सेटिस्फाइड बाय एनायंस. प्राइमरी वैलेंसी विल बी सेटिस्फाइड बाय एनायंस. उसको चाहिए नेगेटिवली चार्ज आयंस. ओके, नेगेटिव ions. Then secondary valencies may be satisfied. यहाँ पे भेदभाव बिल्कुल नहीं है. ओके, तो इसको either satisfied either by anions और neutral ligands. तो उसको नो प्रॉब्लम, उसको कोई भी चलेगा. लिगैंड नेगेटिव हो या फिर न्यूट्रल हो, इसको प्रॉब्लम नहीं है. उसको बोलते हैं हम लोग थर्ड पोस्टुलेट. ओके, सेकेंडरी वैलेंसी इज सेटिस्फाइड और मे बी सेटिस्फाइड बाय एनायंस और न्यूट्रल लिगैंड्स. ठीक है. देन द लास्ट वन सेज सेकेंडरी वैलेंसीज हैव फिक्स्ड स्पेशियल अरेंजमेंट. स्पेशियल SPATIAL मतलब स्पेस में जो अरेंजमेंट है वो सेकेंडरी वैलेंसी का फिक्स होता है, और बिकॉज ऑफ दैट a molecule or coordination compound gets a fixed geometry. Okay, मतलब प्राइमरी वैलेंसी बाय प्राइमरी बाय एनायंस, सेकेंडरी वैलेंसी बाय एनायंस या फिर न्यूट्रल लिगैंड्स, और तीसरा मतलब अपना जो फोर्थ पोस्टुलेट है वो क्या बोलता है, सेकेंडरी वैलेंसी का अपना एक खुद का प्रॉपर ज्योमेट्री फिक्स होता है. ओके, सो दीज आर द फोर पोस्टुलेट्स. एक बार खुद से लिख के देखो एंड प्रैक्टिस इट वेल. It will not take more than 5 repetitions. Okay, so please practice this. It is important. It is important. Okay, chalo. So let's move to the next topic now. In next lecture, we'll discuss about IUPAC, effective atomic number rule, and the very important VBT, along with isomerism. Okay, so 4 topics are pending from this, out of which in exam question can be asked on all 4. Okay, so let's move to the next. Take a screenshot. Okay.